Okay, let's continue our discussion of atomic structure, looking at something called an atomic mass unit. An atomic mass unit is defined as exactly 1/12 the mass of one carbon-12 atom. The fundamental charge of an electron, as we discussed before, equals the magnitude of the charge on any electron, and it equals 1.609 times 10 to the minus 19. The atomic number, or Z, is the number of protons in the nucleus of an atom. It's the number of protons in the nucleus of an atom. The mass number, or A, is the number of protons in the nucleus of an atom plus the number of neutrons in the nucleus of an atom. An anion, is an atom that contains one or more electrons that will exhibit a negative charge. Now what that means is that an anion has one or more electrons more than the number of protons. An atom that has no charge has the same number of protons as it does electrons. But if you have more electrons than protons, then you will exhibit a negative charge, and that atom is then called an anion. A cation, on the other hand, has one or less electrons compared to the number of protons, and therefore it will exhibit a positive charge. So let's go through these again briefly. The mass number is the number of protons in the nucleus of an atom. This defines what the atom is. If it's mercury, which is shown here, or if it's zinc, or if it's whatever, it's defined by the number of protons. And if you change the number of protons, you no longer have mercury or zinc, you have something else. The mass number is the number of protons plus the number of neutrons, and I'm sorry for the error on this slide, but those two added together make up the mass number. An anion is a negatively charged atom because it has one or more electrons than the number of protons. So for example, if it has 12 protons, it'll have to have 13 or 14 electrons to have a negative charge. Conversely, an atom that has a positive charge is called a cation, and it has one or less electrons compared to the number of protons. This is a way of showing, or a symbolic way of showing what we just talked about. This is called a chemical symbol, and it's an abbreviation that we use to indicate an element or an atom of an element. On the left is the example of helium. The number at the top left is the mass number. The number at the bottom left is the atomic number. It says often emitted because if you have the element helium, you know automatically you have an atomic number of 2. If the helium is charged in some way, that is, in this case, it has a positive charge of 2, that means that it will be shown on the left as a superscript. So in this case, this atom has 2 protons and 2 neutrons, thus a mass number of 4, and no electrons in order to have a positive charge of 2. If you look at magnesium over here on the right, you see that it has an atomic number of 12, so it has 12 protons, a mass number of 24, so it has, if you subtract 12 protons from 24 total, that tells you that there are 12 neutrons. It has a positive charge of 2, and therefore, if you subtract 2 from 12, you know that you have 10 electrons, or 2 extra protons, giving it the positive charge of 2. The symbol for an atom indicates the element, and it's usually a 2-letter, although some are 1-letter symbols. The mass number is, again, the left superscript. The atomic number is the left subscript. and the charge is the right superscript. So let's take a look at these and answer the following questions. It says give the number of protons, not protein, protons, neutrons, and electrons for each of the following. So the first one, Si, which is the symbol for silicon, 12, 24. And actually this is not correct because as I showed you in the last slide that magnesium actually has the atomic number of 12. And so we know that this can't be silicon. So let's write this again as 24, 12. It's actually magnesium, has to be magnesium because that's the element with an atomic number of 12. It will have, atomic number 12 means it has 12 protons. 12 subtracted from 24 means it has 12 neutrons. So you add those two together to get the atomic mass, which is shown as 24. And there's nothing here, which means there's no charge, which means you have to have an equal number of negatively charged particles, so you have to have 12 electrons. The second one here is S, which is sulfur, 3216, and it's a -2 charge. So you start out, you have the atomic number of 16, which is consistent with sulfur. So you have 16 protons. 16 subtracted from 32 is 16, so you have 16 neutrons. And this has a -2 charge. So if you subtract a -2, so if you subtract a -2 from 16, you get 14 electrons. Or, I'm sorry, 18 electrons. Subtract a -2, you get 18 electrons. So there are 18 electrons, 2 extra electrons that causes the charge of -2. Now down here it says, give the symbol for each of the following. Now you'll have to look at a periodic table of elements in order to do this. The periodic table of elements can be found in several different places. You can just Google the periodic table of elements and find a periodic table of elements. Or you can look in your book. In a couple different places, you'll find the periodic table of elements in your book. Once you find a periodic table of elements, you can do these problems. Taking a look at the first one, 17 protons. Okay, if you look at the periodic table under 17, you find that that's chlorine. So first of all, your symbol is chlorine, and it's going to have an atomic number of 17. 19 neutrons, so if you add 17 and 19, you get 36. So your atomic mass is 36, and you have 17 electrons, so those are the same, so there's no charge. So this is the answer to the first question. The second question says 19 protons. Again, if you look under the periodic table, you find that the symbol with an atomic number of 19 is potassium, which is K. And its atomic number is 19. It has 20 neutrons, so 20 plus 19 is 39. And it only has 18 electrons, so there's one extra proton, so it has to have a +1 charge. So that's the symbol for that. Now the atomic mass of a single atom is approximately equal to its mass number. And the reason it says approximately is because of the presence of what we talked about before, that is the isotope. And this is an experiment that was used to show that isotopes exist. What happened is that the magnetic field deflected the lightest members the most, and the heavier ones the least, and showed on the right here that zirconium was actually made up of 5 different isotopes. And the average mass is what's known as the atomic mass. So the weighted average of all the known isotopes is what is called the atomic mass. So the atomic mass is the sum of the fractional abundance of any particular isotope times that's isotopic mass, and so forth. For example, if you look again on the right here, this is about 52% of zirconium-90. So it would be 0.52 times 90 plus approximately 11% of 91, so plus 0.11 of 91, and then so forth until you had all 5 and you added it up, and it would come up to some number that was around, say, 92.5 or 93. So let's take a look now at how these calculations are done. If silver has the following 2 isotopes, what is the mass, atomic mass? And it shows here, I'm not going to read those numbers, but here's how you do this calculation. So it's the average, weighted average. So you take 0.5186, and that's this 51.86%, times 106.90509 plus 0.4814 times 108.904, 70. Now make sure you know how to do this, because this will be on a quiz. This sort of problem will be on a quiz. So you do this and you come up with an answer. Now I'm not going to do the calculator part here. Magnesium has the following isotopes. What is the atomic mass? Stop the video for a few seconds and write down how you would set up your problem, and then turn the video back on and watch how I do it. Okay, so 78.99%, so 0.7899 is multiplied by 23.98501. So that's the first one, plus, and the second one is 10%, so 0.1, pretty easy on that one, times 24.98583. And the third one is 0.1101 times 25.98259. And so you multiply this and this and this, and then add all 3 of these together, and you get the answer. This is a picture of Dmitri Mendeleev, and he put together something known as the periodic law. And the periodic law was the idea that the properties of elements are periodic functions of their atomic numbers. And we'll talk about this in greater detail in the future, but he put together this table called the periodic table, which is divided into groups and rows, and showed that elements in the same group tend to have the same types of properties. So sodium, potassium, and so forth in that first group would have the same properties with each other, and on the other side, chlorine and bromine and so forth on the far end on the right would also have the same sorts of properties with each other. The periodic table is the arrangement of these elements in increasing order of their atomic numbers, and then grouping them together in vertical columns. This is a modern periodic table showing all the elements that are known. What you have is on the left is the metallic elements. In the middle, not actually in the middle, but over on this side right in here are what's known as metalloids, and then the non-metals are over here. And most periodic tables will give you this information right here, but also you can see in some periodic tables you'll see additional information. A period or series is the elements in horizontal rows. So you have 1, 2, 3, 4, 5, 6, 7 horizontal rows or periods. And then there are 18 vertical columns or groups, and the groups are much more important than the periods. This shows the general outline of the elements. You see on the left the alkali metals in the first group, the alkaline earth metals in the second group, and then over on the right you see the noble gases on the very end, halogens next to that, chalcogens next to that, etc. And we will talk about this in much more detail in a future lecture.